Okay, so question was, why do we have the receptors for the hormones, yes, and how we can use them? What is the cause that we have some receptors for the hormones? So generally, receptors for hormones are located on the cellular membrane. When hormone will attach to such receptor, then there will be a signal transduction, as many of you pointed out. Maybe let's get this example. Yes, so we have different types of the receptors, obviously, but all of them have the same, maybe not the same, but the very similar common patterns. Yes. So we have, in case of the endocrine receptors, we always have some substance, some hormone, that is attaching to the receptor. Receptor is nearly always, maybe not always, but nearly always, the protein that is inside the cellular membrane, that has some part that is outside and some part that is inside the cell. So the hormone obviously will attach to the part that is outside of the cell and will activate the inner part. Yes, so when appropriate hormone would attach to the outside, the inner part would be activated. And then a lot of things can happen. Yes, generally, those a lot of things that I mentioned is signal transduction. So for example, it may lead to activation of the protein kinases, activation of the creation of the CAMP, CGMP, a lot of different things. We'll also talk about this a bit more in different presentation. But generally, idea is that something is attaching to the external part of the receptor and internal part of the receptor gets activated and it starts the signal transduction mechanism. Why it's important? It's important. Maybe before we get to the picture 3, just to get here. Not all of the receptors are on the cellular membrane. Some hormones, like the steroid hormones, are able to get through the cellular membrane and get into the nucleus, controlling a bit the expression of the genes. So generally controlling what proteins would be created in the cell. So, one more time, some hormones, some receptors for the hormones, most of them generally, are on the cellular membrane, but some are inside the cell. So when the hormone can get through the cellular membrane on its own, the receptor can be deeper, but usually hormones cannot cross the cellular membrane. Yes, it's impossible. Usually, the hormones needs a receptor on the cellular membrane in order to be able to reach it. And general receptors, when activated, would start the transduction mechanism that will pass the information to all relevant places in the cell. So why do we have it? For example, we have such substance like adrenaline. Adrenaline works differently in different parts of the body. For example, adrenaline in the adrenaline in the heart will increase blood flow. Adrenaline in the for example, guts will decrease the blood flow. Yes, because adrenaline is the hormone, fight or flight hormone. Yes, so the hormone that is activated when we are in danger. So generally speaking, it needs to activate everything that is connected to our ability to move efficiently, to act. So our heart, our muscles need more blood. Our guts, for example, can live without, because it's not time for eating, generally, or digesting. It's time to fight or flight. So how to manage it? Because we have the same hormone that is released in big quantities, and has completely opposite effects in two places. As I told before, in guts it will reduce blood flow. In heart it will increase blood flow. So how to achieve this? We can achieve this through very smart mechanism. Different receptors are in the heart and different receptors are in the guts, for example. So the blood vessels in the guts has a receptor, alpha receptor, that when activated will lead to the vasoconstriction, so reduction of the blood flow. In case of the heart, we have the beta receptors, and beta receptors, when activated, will cause the vasodilatation, so increased blood flow. So the same hormone would activate different receptors and leads to different responses depending on what receptors we have in specific tissue. Okay, I suppose it's enough for today.